Imagine that you want to build a classifier based on local texture information. It can be in a medical diagnostic problem. It can be in a quality control problem. In this tutorial, I will walk you through an example on how to build classifiers based on color and texture in a rock sorting application. We start with a directory full of RGB images of rocks. Let's load one of them and import it into per class. Now our image is a dataset. For each pixel we have one sample, and we have 3 features corresponding to the R, G and B channels respectively. To build a representation, we want to compute features only on the rock, not on the entire image. The first practical thing is, therefore, to detect the rock. Let's do it with a simple background detector. We apply the detector to the data and extract a subset of foreground pixels. Our data is now smaller. It contains only the rock pixels. To describe the rock, we would like to use local texture information. With per class, this can be easily done not only for rectangular images, but for any arbitrary object shape, such as the rock we have just segmented. For example, this is the grid 20 by 20 pixels with a step of 22. Now we will compute a local texture information in each of these neighborhoods. We can do it with sdextract command. Per class has implemented several feature extractors, such as local histogram or co-occurrence matrices. But you can also call your own MATLAB script with a feature extractor that you have implemented. Here I'm using my function, computing heraldic features on each color channel. The features are computed for each block. The result is an SD data object. We can visualize the feature values in the original image, but we have only few data points. Therefore, we can shrink the image to the grid points only. In this way, we can visually inspect the different features. We compute the features for the whole training images and have them together in an SD data object. We can inspect the data, we can change the features along the axis, we can view the data with different sets of labels. Apart from the mineral type, we have rock indices, file names, or country of origin. Wouldn't it be great to visualize where a specific sample comes from in an image? It is actually very simple with a custom callback. In sdscatter we can cycle through individual rocks, and then by clicking on a sample we execute the callback that opens the corresponding image in another figure and highlights the neighborhood. We can now train a classifier on the training set, for example, Fisher linear discriminant. Let's load a new test image, compute the feature representation, and apply the train classifier to it. Every region will get a label. As we see, majority of regions were classified as struct. Ultimately, what we need for rock sorting is one decision on the entire rock. In the next tutorial, we will see how to fuse the local decisions into a single one and how to optimize the rock sorting system. Summarizing, we have seen how to extract features in local image regions, how to connect feature and image domain, and train a classifier for the image regions. Thank you for your attention.